So to do some of these probability rules, the easiest way to do them is with examples. So I'm going to re-put the examples up of the Venn diagrams. And this may seem like repetitive, but I just want to make sure that we're understanding the idea. Let's say I made this one juniors and this one seniors from before. I believe there was 149 juniors and 153 seniors. So to find the probability of, let's say, a junior, you would take the total amount of juniors over the total number of students all combined, which I think is 302. And that's the same type of probability that we've been working with. To be able to do like where they intersect. How about juniors intersecting with seniors? Sorry about that. There's nothing, there's nowhere where they overlap. And if you were to unite them, you would take all of them because you want to use all the students combined inside the Venn. So when you're working with probability, the probability of getting, I'm going to start abbreviating, a junior or a senior, there's 302 possibilities out of 302 total possibilities. So uniting would be everything. Or you can even break it down further by saying it's the same thing as the probability of getting a junior and the probability of getting a senior added together. The probability of getting a junior is 149 out of 302, and the probability of getting a senior is 153 out of 302, which together makes 302 out of 302, or something that equals 1, which means it will always occur. No matter who you pick from this, there'll be a junior or there'll be a senior. For mutually exclusive events like this, the addition rule is if you're taking A or B, the probability of A or B, you just add the probability of A and the probability of B together to get them combined. Let's see. I think that's all I wanted to say about this one. But let's do something that overlaps, that are not mutually exclusive. I'm going to put in set A, lowercase a, lowercase b, lowercase c. In the middle, I'm going to put D, E, F. In B, I'm going to put G, H, I. And on the outside, I'm going to put J, K, and L. So let's find a couple things. Like, what are the contents of set A? So hopefully you're seeing that it would be everything inside that circle. A, B, C, D, E, and F. Even the shared parts. And what's not in A, we put this little C up there. So what's not in A is everything outside of that circle, which would be G, H, I, and J, K, and L. So notice the complement and the set combined would be everything in the Venn diagram. That's why we do that complement rule is, and I'll show the probability. The probability of getting an A set, something from set A, there are 6 of these possibilities here, so 6 out of a total of 12 letters, or 1/2. Probability of not getting an A is 6 out of the 12, or 1/2. Complement rule again was the probability of not getting an A is 1 minus the probability of getting an A. Total, they'd make the whole thing. So they'd make 1, and if you take the probability of getting an A away from 1, you'd be left with the probability of not getting an A. And that's that complement rule. A couple more things that I wanted to talk about, just to recap. A united with B would be all the items in the Venn in A, in the shared space, and within B solely. Where they intersect is just solely D, E, and F. And let's start looking at the probability of A and B. A and B, there are 3 choices. So there are 3 positive choices out of 12 letters, or 1/4, or 0.25, or 25%. Any of those are fine. The probability of getting A or B is there are 9 up here out of the 12, which is 3/4. The probability of A and the probability of getting a B, probability of getting an A was 6 over 12. The probability of getting a B would be the same thing, 6 over 12. But technically, we can't have 12 over 12. That's everything in there, in addition to the parts outside of that Venn. We don't want to include those. Technically, DEF is used twice in here, once with A and once with B. So we have to take off the probability of where they overlap, which is 3/12, and that would give us the 9/12. This is the addition rule for non-mutually exclusive events. So I want to make sure that we had all that down.